Okay, round 2. I'm gonna spend 1 more hour trying to solve this. And then if I can't do it, then I'm gonna look at the solution. Or watch videos about other people trying to solve this if I can find the solution online. And then I will continue, I think, for another 2 hours trying to solve the other challenges. I think it's just not. I'm just spending too much time on this specific challenge. And unfortunately, I don't have a lot of time just to play this game, so. But I do want to figure out how to solve this. So obviously I didn't look at anything online. So, and I haven't tried to do this. I just thought about it for a little bit, but decided to rest more because I wasn't getting anywhere. Yeah, so the first input has to save the second input. Save the value of the second input. And has to always output that value 1 tick later. So whenever this is on, it has to capture the value. But when it's off, it just outputs the value that it captured before. So it has to pass through the outputs, I guess. So yeah, here we go. Here we go again. So I think it needs to be something like this, where I connect it twice there. But then, yeah, that's gonna be a problem because it has to be more complex here. Otherwise, it's just gonna work as this gate here. But when this is off, this shouldn't pass. And when this is on, it should pass. But how am I gonna store the value? That's the question. So if this is on and it passes, if this is on and this is off, then it shouldn't pass because it should output off. So maybe I should do the thing that the JSON told me to do, which is to write it down, the possibilities there that I want to achieve. So when the first one is on and the second is off, the result's gonna be off. The second one is on, the first is on. Then I need to change the output on the next round. Change on next round from 0 to 1. But I have to wait for 1 round. But what if it's 1-1 in a row? Then it doesn't matter because it's still gonna be 1. And what if it's 1-1 and 1-0 after that? Then it doesn't matter because it has to output 0. Yeah, but then it has to save. It should output 0 on that round and then save the 0 state. So how I'm gonna do this? Because if it passes through here when it's on 1 and 1, it should just output 0 and 0. I should just output 1, 1, 1 for all the other ones. So how I'm gonna make it so this 1 when it's 0 stops the output on the next round. Because it has to cut through here and it doesn't make sense. Let's make another gate here that is connected to both of them. Like this, 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 and this. If I do it like this instead, I'm obviously not gonna pass now, but I just wanna think about what potential problems might be. So when this is on, when both of them are on, let's think about that scenario. So when both of them are on, I should change the next round from 0 to 1. So what if, yeah, what if it's 1, 1, then I wish, maybe I should do it in paint instead. Can I do numbers here? I think I'm just gonna do a shitty draw. Doesn't matter. So let's scratch this. So when it's 1, 1, I need the output should be, and the output is 0, that should be 1 on the next row. But then if it's 1, 0, the output's gonna be 1, and I need it should be 0 on the next row. I think that's the most challenging part. I'm not understanding how to do. Because I have to think about how to break the flow of the current when this is off, but only on the next row. And at the same time, make the opposite, which seems that doesn't make sense. So if I have a situation where it's on and on, then and the output is off, then it's gonna be, I'm gonna have to make it on the next row. But if right after that is on and off, then the output's gonna be on, still on, but then it needs to change to off again on the next one. Which doesn't make any sense to me. At least not if I try to do it this way, because maybe if I put a delay here as well. If I put a buffer. So I need to think what kind of gate do I need as well. So when this is off, you need to, when this is on and this is off, you need to turn it off in the next round. This is on and this is off. Which means that this has to turn it off when one of them is off. And the NOR gate accomplishes that, but I think it's the only one. And the AND gate. But what if they both are on? I don't necessarily want to change the output. If they're both on, then it means that in the next round it's gonna be on. So I can put a delay here. If they're both on. I put up here so it doesn't get too confusing. I think I can do like this. So when they're both on, it's gonna pass directly here on the next round. When this is on and this is off, let's say here is on. Then I have on and off here. It means that the next round, this is gonna pass, it's gonna continue making it on, so it doesn't work. So maybe, yeah, but if I do it the other way around, not sure if it makes sense as well. Yeah, it doesn't because this value can control the output. That should be the first one that controls it. So it doesn't make sense to do it like this. Oh, actually, if this is on and this is on, then it has to output on. Yeah, but if this is on and this is off, that's what I'm trying to solve now. So it has to output off in the next round. So I need to merge this to negate, but then I got a problem because I can't use directly there. Otherwise, it defeats the point of this whole thing. So let's think about this situation. This is on and this is off, and this is on. Let's turn it on. I can turn it out. This is on, this is on, and this is on. Means that the next round is gonna be off permanently. So I need to find a way to signal through this to break this, but only when this is on. To break this loop here. So I think the best way is probably to separate this on this loop here. And then have something here that does the logic that I want connected to this. So if this is on, let's say this is on, and I want to turn it off because this is off. So it means that I can't stop the current here. But how I'm gonna signal that? I'm gonna make it stop there. Maybe I connect it to here. Well, maybe this way is right actually. I just need to put a delay here and figure out which gate to use to stop when it's on and off. I can make this a loop. Yeah, this one is gonna stop there, but because now this needs to be going. And if I connect this one directly here, it doesn't work as well. Let's see about this. Yeah, now it should go there. Or it should be off. But how I'm gonna signal? If this is always on, we can signal. Should be off. I think I'm getting the logic, but in the wrong way. Because this is on, it should. I'm not sure if I can make a signal here that makes the loop stop on the next round. Where is the end gate? And maybe I need to connect both of them in one and both of them in another. And then use a different logic depending on which path it goes through. So let's see, if this is on and this is off, you can't change the output on the same round. So it has to wait for the next one. Which means I should put a delay. And here, maybe the delay doesn't go here. So if both of them are on, it's gonna activate this one. And when that happens, I want it to wait around another round and activate. And if this is on and this is off, it should be off. So maybe I should connect this directly through here. So when this is on and this is off, or it doesn't pass here. But it needs to activate on this round. That's the issue. What about when both of them are on? Yeah, but now it would have to output the on state and save the off. So this doesn't work. Yeah, I think the end logic works for the save button because both of them are on, has to turn it on the next round, so it uses the delay. And when it's on and this is off, it doesn't activate, which is gonna make the output. Yeah, but that's the problem. I need a way to cut the output if it was wrong previously. So maybe I can achieve this through here, but Yeah, but if I think separately about the save, the end with the delay should work. Just start the state of this second one and change the output. So what's the exception here? So what happens when this is on and this is on, and then the next round this is on and this is off? Well, it's gonna turn it off because unless I put the delay after, because the delay should be directly connected there. So maybe if I do it like this directly here, and then use a separate logic for this one. Yeah, when they, yeah, this should work, I think. So now I need to find a way to make it so that this signal from here makes this gate activate, or let me think about what exactly do I need here. Let me do it on a different color. But I'm hopeful about this logic. I think it makes sense. So let me think. What should happen when the first signal is on? Yeah, this I think is taken care of. But this should cut the current. Yeah, that's the problem. When this is on and this is off, it should stop going through here on the next round. Yeah, that's what I need to achieve, I think. And this is on, this is off. If they're both off, it should be, it doesn't say here. If they're both on, then it's gonna pass on the next round, which works. Then if this is on and this is off on the other round than that, then this one has to cut. So this has to be an OR gate, I think. Maybe if I put it directly there, it works. Let's see. When they're both off, it doesn't work. So but maybe I need to put a delay here as well. Um, Let me test this, see where it feels. So the top one is on, the bottom is off. And it should be outputting the on state because it's saved here. So this is saved, then activated there. What happens now? So the issue is that this thing, so I need to make a loop here, I think, because it stops going from there. Let's see. Yeah, but now it fucks up the thing. Yeah, because it's not gonna wait. So maybe if I put another buffer here, but then I'm not sure if it's gonna work. Because it might be out of sync there. It still turns it off. So maybe not this one. Yeah, but the NOT gate is not gonna work as well. Yeah, I need to maintain the on state there. That's the problem. How do I maintain that state after it passes through here? Yeah, but if I maintain the state, then I can't turn it off. That's the problem. So I don't think it's gonna work this way. Yeah, I can't use this gate here, I guess. Maybe I can use the NOT to turn it off. Or a different gate here. Yeah, but that still gives me issues. Let me see what's happening here. So this works should make the input stay on. Hmm. Now what's the issue? Now it's the same one that I stopped before. The output should be off because it's saved on the previous row. The off state. So here. So this should make the output off somehow. And if I make this an XOR gate, let me see. Breaks down on the same level. It does break on same level. So when this is on and this is off, should pass. When they're both on, should pass. It passes through here. So when this is on, this is off, should pass. So maybe the XOR here. Then I connect directly through here. But then it's gonna pass directly and it's gonna fail. Let's see, when both of them are on, it's off. So it might work actually. Let's see. Oh, it's the delay maybe. Maybe I need a delay here as well. Oh god. The issue is that I'm not turning this off. How did it pass the previous one? I wish I could go back. I guess I can just change directly there. So now I have passing through here. So this one isn't passing, it's just showing up here because probably comes from here. And that's why it's closing there. Yeah, so the issue is that this one is turning the output off. And it's, well, it is meant to be off, actually. But then when I run it again, it's because of the delay here. And if I put directly, I don't think it works as well. Because now the output should be on, but it's not. What if I change the placement here, but it doesn't feel like it's the right thing to do. Even if it solves the challenge. That's probably not the best idea. Change this to the OR gate, doesn't work as well. Maybe I can use the NOT to turn it off when I want it. Yeah, but I'm not sure how to do that. Maybe if I put another gate. Connect it through here and then through here. Yeah, but then doesn't work anyway. I think I have to change here before guess there. But I can't use another gate here to connect there. Because then it's gonna screw up the situation when both of them are on, I guess. Like if I do something like this, so when this is on and this is off, that should change the outcome of this. And need to stop the thing from coming here. But then it's not gonna work with the OR gate. I can just stop here before that. think it has to be connected with both of them, otherwise there's no way to tell when this is off. Well, maybe it doesn't matter because yeah, but the question is how I'm gonna break this current here. I need something that maybe this has to be the AND gate, but I should turn on the rounds that they were both on. Yeah, but if I make this an AND gate, then if it's off, it's never gonna open anymore. So it can't be the AND gate. If I make the XOR gate, I don't think it works as well. Maybe it does. Maybe it does. Because I can use this one to control the off input. But isn't that the same as using the OR gate? The only difference is when they're both on, it's off on the XOR. Which means I can use it to deactivate. When I want this to be turned off, but it's turned on. Now the only question is on this previous one. So when it saves the off value, how can I do this? This is on, this is off. Yeah, it needs to turn this on. Well, both of them are on. Passes through here. This turns off. Both of them are off, or both of them are on. Does this make a difference, or can I connect both inputs directly here? I guess it does make a difference. But then it's gonna turn it off when either one is off. So let me see what's the problem with this. It stops on the first one. Because they're both on, but the output needs to be off. So what if I delay here instead? I need to break this one when this happens. There's no gate that achieves that. Maybe if I just do this, it's done. Because it's passing through here. So what's the truth table that I need there? The first one. I need it to be. When do I need it to pass? When it's 0, no. All situations where it's 1. 1 is 0, 1 and 1. Yeah, that's pretty much it. So if it's 0 and 1, can't pass. If it's 0 and 0, can't pass. So 1 and 0 has to pass. 1 and 1 can't pass. But 0 and 1 can't pass. So these ones can't pass. How can I achieve this? And that's the other thing. If it's 1 and 0, then it has to pass, but it has to deactivate her. Only when both of them are true and wanted his output should go there. Maybe this doesn't need to be connected here. But if it isn't, then I have a problem also because I need to turn it off. Oh, if connect directly through here. The question is, how do I turn this off when it's 1 and 0? The next round. They both need to be on, so it needs to be passing here. Maybe the NOR gate works. And I just take this. I feel like I tried this before. Yeah, it actually doesn't turn it on. It has to be the opposite, I think. The XOR. But the XOR is gonna activate. God damn, already 1 hour. I feel like I'm getting close. That's the problem. Maybe I'll give it more 1 hour. Then, if I can't do it, I'm just gonna search for it. And the issue with the XOR gate is that I just wanted to activate. So maybe I can use a NOT here. Here. the opposite input. But it's not, so it's gonna be on. Just always gonna pass. Which this should only turn on when this is on. Yeah, when this is on and this is off. All the other situations can't do. So how can I achieve this? So maybe I need to add a gate here. This is on, this is off. It activates here. When both of them are on, it's gonna activate. No, it's gonna block here. Maybe I found the one. Yeah, but that still doesn't answer the question of how I'm gonna stop the loop. No, if they're both on, it's gonna break the loop. So maybe it works. So let's see what's happening here. It's passing through here and it's passing through here. Oh, it's because of the delay. But I remember there was a problem with doing this. So what's the issue now? So it is off and on, but it should output off because it's saved off before. And then it's blocking the input here. But it should be working. So maybe if I change this gate. Let me try all gates because I don't want to think about it. They all fail then, I would think. Yeah, this one, so far, XOR is the best one. Yeah, our gate's obviously not gonna work. And maybe I should try just for the sake of it. Yeah, I think that's about it. It's passing through both. Then activates the next round because it's pushed through. It should be active still. But now it's passing through here. Yeah, so this is telling it to save this state here. Which means it should output off in the next one. So it's correct. And now the problem is it should keep outputting off. And why is this? Oh, it's because of the delay. But I don't understand. Maybe if I separate them with an OR gate here. I think I'm gonna, oops, make this more through here. No, it's at least it's better to understand where the problem is. What if I put this? Yeah, so the issue comes now, I guess. Or maybe in the next round. Because the next round is going to activate this as well. I just don't understand this delay stuff. Because it seems to be on here, then I guess it delays the output of these ones. Oh, the issue is here, not here. Because this one should have stopped. So let me see that again. Yeah, because when I'm stopping the loop, it fucks up this one. Because it stops receiving current here. So maybe I should use the always on instead. Hmm. But now I should change the logic here. Yeah, but then that doesn't work. Because I forgot that I need to attach to here. So it doesn't work. The whole point of doing this is that the state of this one is going to be activated by the state of the save here. So I can't use the OR gate, the ON gate. So when you turned it off, which was this round here, yeah, turns off, then the next one. I need to find out. We need to find a way to turn this off. To turn it on again. Or actually, not even that, it needs to be off, but to stop this from happening here. It's weird that in some outputs it works with the off state. Problem is if I use a NOT gate to keep this state on, then I need to change the whole logic of the rest here. And I copy schematics. If I add the delay, but then it's gonna screw up all the other ones. Add another one here is also not gonna work. What if I try changing the XR gate? Yeah, not very hopeful about this. Because then it's never gonna turn it on. Maybe I can also put this here. Or I can't. Yeah, this one here should be cutting the current the next round. And I was achieving this through this one here. So let me see if I do this. Yeah, so this achieves what I want here. And then it fails on the other ones. Or maybe I can do both, actually. Yeah, if this works. What if I put a delay here? So why is this passing here? Shouldn't it be off? Both of them are on. What? Doesn't make any sense. They're both on and it's passing the currents. Don't understand. Let me do the same way that I was doing there before. Just put the delay here instead. I don't understand why this is passing and they're both on if it should be off. It doesn't make sense. What? Maybe it's bugged? I don't know. It's kind of crazy. Oh, it's passing through here. Mm, that's what's going on. Yeah, so I need to link it directly through this one. Hmm. Yeah, so now it should be passing. So I guess if I put this there again, it might work. What is going on with this, man? I'm gonna have to watch a video of someone doing this. Probably right now it's being, I don't know, maybe 5 hours or even more. I'm trying to do just this challenge alone. The closest one I got was that solution where it was very simple, an XOR gate, but it feels like very hacky, that one. So what happens when I cut the link here? Now it passes these ones because Yeah, this one is the one that screws things up. I feel like this is not gonna work as well. Attach here. Yeah, it just doesn't work. So I don't think there's a way to maintain that one. Maybe with the NOT gate. So I'm thinking about doing something with the NOT gate. So what's the situation? See again. It's the situation that I'm saving the breaking state. Where I need to keep this going. So maybe if I attach this thing here to the NOT gate. Yeah, just doesn't work. I think I'm gonna try this, but probably it doesn't work either. Yeah. Yeah, the only way that I see is changing the logic of this thing. But then it's not gonna work because I can't. I'm not gonna be able to use the output to change this one. This would work perfectly if it kept going here. It's the only issue. Because now this is gonna stop and this is gonna output off. Output on. I mean. Maybe one more delay. Feels like if I do that, it's gonna change the output of the other challenges. And that's the problem. And then it's not gonna solve that issue anyway. So what should do? Oh, I forgot about this one that I did. What should do? No, alt click to move wire. Oh, damn. I'm so dumb. Yeah, I don't know. And this was the closest one I got. Yeah, from the concept standpoint, this doesn't feel like it does what it's supposed to do. That's the problem. So even if it passed all the tests, would probably be better to solve this way. I think I'm gonna look it up. There's no. I'm gonna go to the bathroom first. Otherwise, who knows how many hours I'm gonna spend here trying to solve just this one. Be right back. Yeah, it kind of sucks, honestly, because uh, I really think this is gonna help me be better at programming, but it's not something I can show other people, like a project or something. So I can't spend too much time doing this. But at the same time, I want to solve all of them because I know I'm gonna become a lot better at understanding how the computer thinks if I do this. But I think, unfortunately, I'm gonna have to do this just today, and then tomorrow already start the Kaggle challenges and the free code camp challenges. On the good side, it's gonna become a lot easier, I guess, because this is really hard. So in comparison, the other like coding becomes a lot easier in comparison to this. So I think I'm gonna search for the videos. I don't know if I'm gonna be able to see. I know people did the videos about this, but yeah, maybe this guy here.
See my Twitch, I don't care. My Steam, I don't care if you see my Steam. Hi, hello, hi, and welcome. I know.
Damn, his video is laggy as fuck. I don't know if it's because of the YouTube or sometimes it's weird. Some videos they do
Usual, it's Wednesday. Is it
they're
Wednesday?
really slow and some are normal.
It's Thursday. I'm streaming, but I have vacation, so I'm just gonna do that,
Should close
and
this.
maybe even longer today because hey, I want to. So I don't know. I don't know. We like slowly.
Did this guy just did he do the whole game in under 3 hours? Damn. He probably has a lot of experience already.
Really slowly. I want to understand everything that's going on. A signal flows from in component to the out component. In the upper left corner under input, there is a green icon. Click on it to turn the in component off. Boink, got it. Notice the out component is turned off. This is because the signal stopped flowing from the in component. That makes sense. You stop the in, right? You stop the in, there won't be a signal to the.
Let me jump to the levels that I'm at.
You can select a component with its pins by double-clicking on it. Yeah, I don't really need to. I don't need that. I'm smart enough. Last level, you built a circuit that was.
Yeah, this is the circular dependency.
So what?
So now he's getting close.
After that, this guy mentions exactly what I said. Okay, good. In this level, you must build the set reset latch, which stores memory. This is the only level in the game that allows circular dependencies. It's not the only level. The last level I played allowed circular dependencies. Consider this simple circuit just 2 NOR gates in a row.
Maybe he already passed.
Adding this magenta wire doesn't immediately change anything until we turn the input. Notice the blue wire is now red. It remains like this even after we turn on the red output. What? It's red now? What?
So I think he already solved the one that I was trying to do.
That's better. You're right. I liked my approach. Because my approach was just ands and nots. That's how you build it. Thanks. So circular. What do I make?
So let me see which one I'm on. Yes, there's still a couple of them. I'm curious to see what the solution is gonna be.
Make a circuit where the input of a component depends on its own output. Nope. 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 Wait. What? I don't have the in and out thingy. Which is, I mean, I can take anything. Doesn't matter. I can do this. And then just this, or what? Circular dependency. The output of a component leads back to its own input. Check. Create a circular dependency involving at least 2 components. Okay, I guess. There we go. What do you mean? Like this? Check. Yay, circular dependencies. Hey. I mean, those are important for like time-dependent things, for flip-flops, for example. That's probably why I have on memory. They're important for memories, exactly. You just learned how we don't allow circular dependencies. Now you must learn the exception. I still know my shit, you know? I still know my shit. Whenever I say something, a second after that, like 2 sentences after that, this guy mentions exactly what I said. Okay, good.
So
this level, you must build the set reset latch, which stores memory. This is the only level in the game that allows circular dependencies. It's not the only level. The last level I played allowed circular dependencies. Consider this simple circuit just to...
Mine didn't have this, I guess. Or maybe I didn't read it. Also, it was one level before. Huh. That's strange.
NOR gates in a row. Adding this magenta wire doesn't immediately change anything until we turn the input. Notice the blue wire is now red. It remains like this even after we turn on the red output. What? It's red now? What do you mean? The blue wire, this one is red, okay. We are now trapped in this new configuration. Looking at the blue and magenta wires, it is pretty clear that only one of them can be true at any time. Turning one turns the other false. Finish the circuit such that... Yeah, shut up, I know what it is. The NOR. Yeah, push that to the side and just continue. Oh, okay. Okay, that's great. Hi. Wait, I forgot your name. I forgot your name, but hi, how are you doing? Hey, Eunice. Yeah, it's an interesting game. It's actually, I love the concept. Like, I love, this is called something, gamification. And I love gamification. I completely misspelled it. It's called gamification. Gamification is a method of doing something in a playing sense, because most humans love that. Especially in school, it should be applied more and more and more. And I try to do that in my lessons as well. Gamification. Can I just do... Yes, there it is, okay. Yes.
I think mine was different because I didn't have this challenge.
Yeah. I don't know what I'm doing, so... There we go.
Maybe they change it for later.
I didn't even think about it. This is how a flip flop is built. I was like, it's just like natural. I don't know. I don't even want to think about the circuit because I've built it. I built it up in a lab with integrated circuits. I still remember doing it. I don't want to think about it. If you don't understand it, that means
Yeah,
you
that's why. That's why I built it fast.
just don't understand it. It's on you. It's not me not being able to explain it. It's on you. You should understand it. I don't remember. I remembered it from lessons. I remember how it looks like.
Yeah, let me see. He's on the third one there. So maybe, yeah.
But yeah.
My concern is that it's not gonna. Oh, so here it is. It's probably gonna solve it in
It's more easy. Yeah, everything's
seconds.
okay. Danke. You're welcome. Engineer. Do you mean HHL or engineer? I'm just gonna call you engineer. I'm just gonna give you a different name every time. That's the easiest for me. Today you're Polly. Hi Polly, how you doing? The set reset latch contains 1 bit of information, but in a manner that is not very easy to load or save. Create a circuit that can save 1 bit of information. The first input should determine if we load or save. The second input is the value to save. This value should be ignored if we load. Which isn't that the what? Oh no, it's got a what? I don't even understand the task. I'm not lying. I don't even understand the task. What? The set reset latch contains 1 bit of information, but in a manner that is not very easy to load or save. Okay, great, got it. Create a circuit that can save 1
but his is different here.
bit of information. Okay, got it. That's what we have. The first input should determine if we load on low or save on high. The second input is the value to save. This should be ignored if we load. Oh, that's difficult already. Okay. Let me give us more wake of Haribo. No, I never gave out Haribos. I gave out something. Sometimes I gave out things, but never candy, I think. No, I had like candy. Yeah, I had those sour candies. You're right, I remember. But those were just a gift I got from someone else. But yeah, you're right, I remember those. Anyway. You want to be actress, not engineer? That's pretty cool. Actor would be nice, but I'm not good at acting. You can do it. RS with an enable. Yeah, exactly. That's what it is. Yeah, exactly. Make sure you understand how the set reset latch works first. Think about truth table for the input to set reset latch should look like to complete this level 1. I'll just do this and see what it is. Wait, why does it have 2 outputs? Why does the SR have 2 outputs? Oh, the one is just the opposite of A? No, what? Okay, play button. Got it. First attempt failed miserably because the reset is on. What is the... I cannot even remember SR. Yeah, that makes sense. The R is dominant, right? Input 2 is a reset input, which is dominant. That's why those are off. A. Oh, there we have the list. Oh, shit, I'm an idiot. Yeah, did I also do the money stuff with you? Because that was also gamification. I had like 1 year where I did, like, pushed in money. Postdola. Hey, Gustavo.
So this is an issue. This one is different. I'm gonna watch another video and see if it's
Why you cooking
the same.
Yeah, you can help me.
Or maybe I'm missing something here, but I think I did all of them. They probably changed the game since then.
Gustavo, you have to help me. What are you cooking? Today, I just had like prepared meal today, which I didn't really like. It was okay, but it wasn't too good. No algorithms, no codes, no tie in head. I don't like. Also have to think probably. But I don't know. What math? What is with math, Alex? What is with math? We choose S2 as Rs and feedback outputs back to them. Yeah, Igor, I guess so. And hi. And hello to everyone else, by the way. But oh god. Repeat what A was last set to. Alright, yeah, I get that. Why is opposite of A? What opposite of A is always the opposite? Opposite of A is not always the opposite of A. That's kind of annoying. Not gonna lie. Oh, Gustavo's cooking math. Probably not. No. Unfortunately, that was not in your class. I still have like pictures. Wait, let me check my pictures if I still.
So the thing is, there is scenes here as well. Set reset latch. That's what I need to build. A opposite of A. So there's 2 inputs, and this one's gonna be. This is the opposite of this one. So it's something that transforms the inputs there. Oh, he spent a little time on this one, but obviously solved
right.
A lot faster than I did. I didn't even solve it.
So. Wait, what? Huh? What? Yeah, because I clicked too many times. Okay. The output A is maybe reversed with the other. Yeah, no. The thing is, the output A will be on in the second tick. So if I go tick by tick, in the first tick it's off. In the second tick it will be. What? It should be on in the second tick, shouldn't it be?
So confusing.
Repeat what A was last set to. Hi, Gellert. Hi. Now both inputs are off. But A doesn't reset. A's never been set. Oh god, A has never been set. Yeah, this is yeah, I'm gonna save that for later. So you gotta think about it. You gotta think and explain to me how it works. What is this? What
Yeah,
is this?
so it
Why?
is hard. It's not just me.
Only when an odd amount of inputs are on. This level has a hint. You can use if you get stuck. Isn't that an OR with 3 inputs? Like 4 inputs, actually? That's an OR with 4 inputs, I assume?
I'm gonna search for another video. Yeah, but this was 1 month ago, so probably all the other ones are gonna be different as well. Yeah, I think I'm gonna solve this off stream. I'm gonna look at these videos. Or maybe this one. I'll watch this one first. If this one is not the same, then I'm gonna, yeah, I'm gonna watch these videos and try to do the whole game off stream. Watch the videos. Maybe I'll try some of them by myself. And then maybe I'll show the results on one stream. Or just in one video. Or maybe not, because, yeah.
Well, hello everyone, welcome back to Zombieland Gaming. This is episode number 6 of Turing Complete. We are actually into the building a working computer portion of this. But first things first, we got to cover a couple things that were left out in the comments. One by a person named Zen Dragon, which for some reason they're...
Oh, so he's already far off. So maybe this one. Honestly, I think I'm gonna watch this off stream. And tomorrow I'm probably gonna start the Kaggle stuff. Yeah, I'm gonna start the Kaggle courses and then the free code camp stuff. Maybe depending on how fast I finish everything off, because I have no idea how long it's gonna take me. I think it's gonna take me a lot less time than the first time because I remember a lot of stuff. But it still might take me a while to finish the Kaggle courses and the free code camp, because I wanna go back to the JavaScript portion, then do some of the front end stuff and the back end, and do all the challenges. So I guess that is gonna take a while, probably. But if I'm able to finish them really fast, I might go back and try to finish the game. So yeah, see you then. Probably tomorrow I'll come back and do Kaggle stuff. So see ya.